Please give us a few key facts about the 2015 Annual Congress of the AAPM.
Sure. You know, it's been a great Congress. The weather's been fantastic. We're here in the shadow of Disneyland, and I think a lot of people have enjoyed that. So the total attendance is 4,274 people. Of those, there's 2,713 scientists, and there's 1,143 vendors participating, and we have a great showing from the international community of 834 individuals, so it's been a good Congress so far.
What were the big things at the show here?
You know, medical physics in the United States has really two components to it: radiation therapy and diagnostic imaging. In radiation therapy, the exciting new technology that's been the talk of the town this week is MR-guided radiation therapy. So these are both cobalt-based radiotherapy and linear accelerator-based radiotherapy systems that are actually incorporated and integrated with a magnetic resonance imaging system. And this promises to give excellent guidance, image guidance, to better target the radiation beam to the tumor, and to also allow normal tissue sparing, so you can miss the normal tissue, which is one of the big issues in radiation therapy. In diagnostic radiology, the concept of radiation dose as a harm has been popular over the last several years, and we see that again at this Congress. There's a lot of vendors here that have radiation dose, CT dose reporting software, so when a patient gets a CT scan, that the dose information, it's not exactly dose, but it's dose metrics, are actually conveyed into the radiologist's report, so that is a permanent record that the patient and the patient's physician can access. That's actually a law here in California that went into effect 2 years ago, and now we see that law promulgating throughout the United States through another agency, and so everybody's excited about being able to get that. And the reality is storing the data in an individual radiologist report isn't of that great value, but the database that you build when you do this after tens of thousands of scan is a great opportunity to better optimize the protocol for a bunch of different CT scanning applications, and so it's really leading to better patient care.
Please describe the daily routine in researching in the clinical everyday life over here in the US, so we might be able to compare that to Europe.
Sure. You know, the majority of AAPM members are clinical medical physicists, typically board certified by the American Board of Radiology. Most of them practice in radiation oncology, so they're involved in making sure that the machine, the linear accelerators, are putting out the right amount of radiation that's dialed in on the console, that the beams are targeting where they think they are targeting, treatment planning, and all the other aspects of clinical radiotherapy, including brachytherapy and all the image guidance that we have in a modern radiation oncology department. In diagnostic radiology, we have clinical medical physicists who don't necessarily work so much closely with the patients, but rather with the machines. And so they'll go in and do quality assurance on the CT scanners or their mammo units or the ultrasound systems, MR as well, and make sure that it's operating to deliver the best image quality for the reduced amount of radiation dose for those modalities that use X-rays. In addition to clinical operation, a lot of medical physicists, such as myself, we are involved in research, and so that process involves writing research grants, typically to the federal government, the National Institutes of Health, and if you're lucky enough to get them, about 1 in 15 are awarded. Then you have some money to do some research with, and that usually is what supplies the funding stream for a large laboratory such as my own. And so that's research. So that's dealing with students and postdocs, and sometimes it's computer-based research, oftentimes it's laboratory research, many times you were doing clinical trials with either radiation therapy or diagnostic imaging systems, so it's a wide hodgepodge of different projects as the way research goes, of course. So that's the spectrum of operation. A lot of us are involved in education. Our medical physicists really provide support to both radiology, diagnostic radiology departments, and radiation therapy departments. And so in those two settings, we are very much involved in educating our physician colleagues, especially those in training, residents and the like, in the physics of radiation therapy and radiology. So that's a big component of what we do as well.
What are the challenges you currently see in the field?
Well, a lot of your readers will have heard of Obamacare, which is the Affordable Care Act, and that's changed the way that procedure-based medicine is funded. And so both in radiology and radiation therapy, which are clearly procedure-based, chest x-ray, for example, now there's bundling. So we used to get paid for like an abdomen and a pelvis CT scan. Now you get paid for an abdomen and pelvis CT scan. So it's bundled together, and of course what that means is it's a reduction in pay. The mantra in diagnostic radiology amongst our physician colleagues is value instead of volume. So the radiologists are becoming more involved with consulting with their referring physicians, on occasion even talking to the patients, as opposed to just sitting in front of a computer and pushing out interpreting image data all day long, which is sort of the paradigm today. In medical physics, we feel that we need to follow the lead of our physician colleagues and get more engaged with our physician colleagues, get our heads out of the scanners, out of the mammo machines where we're making measurements and calibrating the systems, and rather take a step back, get involved with the therapist and the radiation oncologist in a therapy clinic and the radiologist and the technologist in a diagnostic imaging setting, and work with them to improve protocols, reduce radiation dose where possible but still give good diagnostic image data, and really working with even the managers of the departments and stuff like that to assure good patient flow. So it's a top-down, higher-level involvement that we're going to be launching a so-called medical physics 2.0 type campaign to try to reinvigorate the folks involved, the medical physicists involved in these departments.
What's going to be happening at AAPM 2016?
Well, we're excited. We're coming from the West Coast here in Anaheim, California, about 15 miles from the Pacific Ocean, and then we're going to move across the country to Washington, D.C., which is, of course, a few miles from the Atlantic Ocean. And that will be held at the Convention Center, which I'm told is quite new, just opened up this year, so it'll be a very nice venue in Washington, D.C., and I believe that the dates of that meeting is that it starts on July 31st, 2016, so we're all looking forward to that, the next Congress.